You like dancing with kids, orphanages. Literally, in the airplane. Weightless. Guess where he's from? Seattle. And guess what his occupation is? Developer. Hey, welcome to the conference, guys. Today I'm going to be talking about service applications. And that was just a little crescendo music to get you all in the room during the transition. Everybody had to get out of here and then bring you back in. So give me 5 minutes less talking time. But hopefully we can get through this. This is one of the very first sessions that I've done in fact, it is the first session that I've done in my recollection where I'm not going to do a demo. Building a service application in 75 minutes would be a challenge. I would be like ripping through code like mad, and at the very end you'd be like, can you go back to the first slide? What happened in that first class? So instead, I'm going to talk you through all of the details. This is the 101 session, right? So if you've already built these, right, if you're already, sort of a veteran, hopefully you're going to get something out of it anyway, because I'm going to try to take you through all of the lessons that I learned as we went through and tried to piece this together. The documentation out there is lacking, let me just put it like that. So I'm going to talk through all of the elements of building service applications. Why you would want to, where we even got this idea of making service applications, right? I'm going to talk through the details of the anatomy of the service application framework within a SharePoint context, right? So how does SharePoint take and build on top of what we had in the past? And then I'm going to talk about the actual details of the service application framework, how you go build your own custom service application, what pieces you're going to have in place. Does that make sense? Does that meet your guys' needs? Yeah? Okay, super. First, remember, we had client-server. That was the very first introduction to 2 machines. And then later we came up with this concept of N-tier development. So let me just give you a little bit of history behind how we even got to this concept of an application layer, right? So we had the presentation layer, which was just about taking the information that we got from some other box and presenting it here. Right? That abstraction or isolation of that information made it possible for us to get the information from various locations over time. So the N-tier concept was born. The data was on one layer, the presentation on another, and in the center was business logic. Now in the business logic layer, we would be able to put the kind of information that needed to be the rules, the heuristics of how that information would be accessed, your security, context, and things like that would all go into the application layer. Oftentimes, we would have to duplicate some of that in the presentation layer just to be sure that we wouldn't get information. But ideally, your presentation layer would just be about showing stuff, right? And your middle tier would be how you would get information out of the back end and present it to the business user. For Microsoft Stack, we had MTS. Anybody play with the Scribble application when the NT40 option pack came out? Am I the only geek in the room? Yeah, all right, dude. So I was up at midnight downloading the option pack and figuring out how the little packets would whiz from one machine to another and present the dot that I drew here as a dot over here. Guaranteed delivered package, right? Through the service application framework, we're going to be able to do something very similar. That is to run code on another server, right, that's going to process data or whatever we want to do and bring back a result, okay? MTS did that for us. It had the rudimentary pieces of an application layer in that we could load up some kind of methods or functions or whatever you want to call them in COM components and put them into a container and then call into that container. Now it had a couple of features that I thought were really nice that aren't part of the service application framework. MTS grew up to become called COM+. So I call the service application framework COM+-, because it has lots of COM+ concepts and lots of COM+-like features, but it's missing a couple of things. Now, COM+, how many people worked with COM+? Okay, a bigger group of people, that's good. So we would take COM components, we would upload them into the COM+ container, I guess, if you want to call it that, right? And you'd see the spinning balls when you had active instances, right? Those things were COM components that had been loaded into memory, just-in-time instantiation, and then when you said you were done with it, when you disposed of it, they would go, well, you might want it again, so we're not going to throw it away yet. We're just going to hold on to it in memory here for a little bit of time. And then if you ask for it again, we'll just go, ta-da, we don't have to recreate this. It was called just-in-time instantiation. Surface Application Framework does not have just-in-time instantiation. That doesn't exist. Right? Second thing COM+ had was role-based security, and that we can actually set up security on these objects themselves so that we could say who could call into that. Service Application Framework only provides us with the ability to create custom permissions. There is no concept of a role-based security built into the framework. Right? The third thing that COM+ provided us, aside from the spinning balls, was an underlying capability called the Distributed Transaction Coordinator, the DTC. The Distributed Transaction Coordinator allowed us to write transactions that would go across platforms so that we could say commit to COM+, and it would go and commit to Oracle, and then commit to SQL, and then commit to the file system, and then commit to Exchange or whatever in that whole process of a transaction that went cross-platform. The Service Application Framework does not have the DTC. It doesn't exist. Okay? So those three things are missing. So I call the service application COM+-. Does that make sense? Everything else is very much like a middle tier application layer container, if you will. In fact, you can kind of get a little picture of what it works like. We've got two servers here. On the left, you see server 1. That's where my actual component lives. It's going to live in some kind of on some kind of a box somewhere. Some consumer, server 2, is going to request that. It's going to make a local proxy on server 2, and so that the application, the consumer, is just going to talk to that local proxy. That proxy is then going to make the determination through some kind of call to the actual server 1 set of servers. It could be more than one application server there, right? And that call will actually be load balanced across whichever servers are available, and then it will be executed on that distant server. Now, the consumer doesn't really know. The consumer is going to make a call to the local proxy. The proxy is going to do all the work to talk to the back-end servers, find out which one to run on, go run the actual code, talk to a database, whatever you got to do, come back with a result, and hand it back to the consumer. So it's a very simple model, and it works just the same no matter whose middle-tier application layer you're using. So for instance, J2EE has a very similar model. You can see on the left, they've got the application server, and on the right are the consumers. And the consumers use certain protocols in order to talk to some kind of a connector. That connector is their concept of a proxy. So that the consumer talks to a proxy, the proxy talks to the application server does the thing it's supposed to do, right? And then it returns back the results so that the consumer can then present that. And it doesn't matter which consumer you're trying to use, the proxy that you're talking to is going to look the same. So it looks like a local call. It looks like a local service call rather than some remote service call. Okay, so that's the concept. No matter whose conceptual framework you're using, you're going to have a topology that looks something like this. Now this is what I call the conceptual topology. This is how it was supposed to work way back in the day when MTS and COM+ were born. So you can see on the far left-hand side, we've got some web front ends. How many people think it's a good idea to have more than one web front end? Why do you think that? Because it's distributed, it's scalable, it's fault tolerant, right? You can load balance it. All of those buzzwords that we like to use, but are so valuable to us because we know that if one of those web front ends goes down, the other one's there to take on the additional load, right? It might slow some things down, but your application's not out of service, okay? Wouldn't it be nice if we had a middle tier, sorry, let me back up for a second. On the far right-hand side, you see the database layer. Wouldn't it be nice if we had multiple database servers that could house, that could farm our databases? Well, the problem is with traditional application layer kinds of things, the database was the single contention point. It was always contentious. We only had a certain number of threads, only a certain number of connections, and the database was the challenge, right? Because everybody was connecting to one common box. What does SharePoint do in order to mitigate the database problem? Anybody know? Say it again. Well, okay, you can do mirroring, you can do special database-y stuff, but you still end up having to have big, beefy boxes on your database back end. Here's what SharePoint does. It says, let's go ahead and separate it out so that each web application, or think IIS website, each web application can compartmentalize its data into different content databases. And those content databases can live on different database servers. So yes, we still have a single point of contention, but I can have a dozen simple boxes all running SQL Server, and my request is going to just go to one of them. It goes to the configuration database and says, hey, where's this data live? And then it goes to a specific database server to find that content in a given content database. So we can horizontally partition data across that layer. So SharePoint 2001, 2003, 2007 addressed web front ends and databases. But what about that middle tier? Nothing. Or we have nothing. In fact, I'll show you SharePoint's history momentarily, but the concept is, what if we could farm our middle tier? What if we could put multiple boxes dedicated to processing requests? So you could offload processing from your web front ends onto some dedicated set of servers. Let's think about it for just a second. Why would that be beneficial? Have you ever tried to run a report on a web front end? What happens to the other users that are trying to make just simple web requests? Tank their experience, right? They're not going to be able to see the kinds of results, the kinds of their level of expectation with regard to the responsiveness of that server is not going to be met at certain points in time when some big gigantic report is running. So years and years ago, we would separate out reporting to its own servers and say, you're going to make report requests over here because we don't want to somehow slow down our web front end traffic just so that you can get a report. So this was the conceptual framework, that we could isolate certain servers, certain computers that would run very processor-intense applications or requests, right, so that they would be over here. And then we could have multiple of those boxes so that we could scale them out. If we needed 5 of them running simultaneously, we could by just adding another inexpensive server. Wouldn't that be nice if SharePoint had a middle tier? Wouldn't it be nice if we could literally have an end-tier concept running in SharePoint? Now, notice the last 3, JIT activation, role-based security transactions, that's the conceptual framework that we're not going to get in service applications, right? That's COM plus minus. So we're going to dump off the last 3 there. The other ones we can actually achieve now. However, when we actually implemented this back in back in the MTS and COM plus days, or even J2EE for that matter, lots and lots of times, when you go to implement this, people say, well, I only have a certain number of servers. I only have this much hardware. So I need to allocate those servers in the most logical way. Notice that on the previous screen, I've got 1, 2, 3, 4, 5, 6 boxes. Expensive. Right on the next one, I've got 1, 2, 3, 4, 5 boxes. Not as expensive, and even maybe more fault tolerant, right? Because now I've got 3 web front ends instead of 2. I've got 3 app servers instead of 2. So people found that most of the time, their application layer was calls to common routine business logic that didn't consume more CPU than any other request. And so they would couple their web front ends and their application tier stuff together on one box. So we ended up with web app boxes rather than web boxes and app boxes. However, there was a problem. What happens if the app gets too big and starts to consume your web front ends? SharePoint had this problem. SharePoint had this problem with search, right? SharePoint had this problem with indexing. SharePoint had to solve this problem long time back. So how did they come up with a new solution for overcoming the problems that when the application processing gets to be too big, it starts to interrupt web requests making their debut, I suppose. Well, before I tell you how SharePoint solved it, here's the sort of the crux of the problem. Why would you want an application layer? Why would you want to go ahead and build out a separate process? When that app gets too big, you want to move it. When it's interruptive. So I came up with these 3 reasons that I thought of. One is to offload the resources, right? Take the resources from my web front end, move them into an isolated, maybe scalable set of boxes. that's fault tolerant and can be built out over time. Start out small, build in more boxes as you need to, right? To dedicate to a certain process that you want to have done and you want it done quickly, but you don't want it to interrupt the rest of the web traffic. That's the first one. Second one, according to me, is the centralization of state. So what if you wanted to have one common set of in-memory state? I'll give you a super simple example. In my book, I hope to have this published. What if we wanted a who's online application? Who's literally online? Now, if you've got tens of thousands of users, is it a good idea to take every single request that everybody makes and log it into a database table? Good or bad? It's a good idea, but is it going to be pretty consumptive of your web front ends? Every single request to every single page that anybody makes anywhere on your farm, you're going to try to log that in a database. I guarantee you're going to have a 10 to 20% productivity loss or performance loss on all of your web front ends as soon as you turn it on. Wow, so who wants to buy, that's 1/5 of your hardware just gone, not available for other processing. What if instead we could say, hey, we want to keep, and we have one more problem too, right? And that's that we've now housed it into a database. So it's an expensive call. We have to keep a connection open. We have to go to a database, pull the data out, format it from an SQL-like data set into some other format. What if we could just store who recently was online in memory in one server somewhere? So what if we could centralize all of the calls for everybody who's doing stuff? So any web front end anywhere would just say, hey, you server over there that we've configured, please keep track of this in memory. So we throw a fire and forget kind of a request over to the service application framework and say, run this on the load balanced set of servers. And the load balanced set of servers includes one and only one server. And that server has an in-memory collection of who's been online in the last 3 minutes or whatever. That service application framework can actually have a timer job that runs once a minute and says, hey, take everybody who's been on here for more than 3 minutes off the list and dump them into a database. Way more efficient and a way better approach to managing a centralized set of state. Now, it's just a simple example, but can you see how that might be useful? I believe that SharePoint is using this, and I'll give you a couple of examples where I think they're doing a centralized state kind of a solution. Okay? And then the last one is cross-platform. Right? If you've got multiple platforms, not just Wintel kind of a platform, right? You've got other operating systems and other hardware platforms, then by setting up some kind of a middle tier, you can have those platforms call in through some kind of a non-proprietary, standardized mechanism by which we can say, hey, go get something and return it. So SharePoint literally becomes the application middle tier host. You can literally set up a farm that just says, hey, this is my farm of all my middle tier application calls. Right? So I can make com plus minus a SharePoint farm. And I think that that's going to be pretty common, actually, as we start to mature this framework. Okay. So why not just use an SMX web service or, heck, a WCF service? Why not just skip this whole thing? And believe me, you're going to. Right? There's going to be times where you're going to go, heck with the service application framework, I'm just going to make a WCF service. Because what does the WCF service give you? Well, I can offload to some other load-balanced set of hardware. Right? I can make calls over there. Right? I can load balance it so I can make it fault tolerant and scalable and all those kinds of things. Right? I can set it up so that I can make direct web methods. It's super simple to set up. We all know how to make WCF or SMX web services. Right? So why not just use a web service framework? And I'm going to tell you, there are times that you should be using a web service or just a WCF approach. It's just easier. Okay? However, the service application framework brings to the table several things that I think you're really going to find nice. First of all, it's hosted by SharePoint, which means that SharePoint is now managing which boxes are running that. So when let me back up for just a second. I want to sort of indoctrinate you into Todd Bleeker's terminology for just a moment. Can anybody tell me what the prime directive of SharePoint is? The prime directive of SharePoint. Nobody? According to me, it's to empower the business user. To empower the business user for self-reliance, right? So that they can do for themselves. We don't have to do for them. We're going to empower them to be self-sufficient. to be self-reliant so that they can handle anything. Think about how SharePoint works generally, and that's primarily the purpose of everything that SharePoint has ever built. The prime directive of SharePoint is to empower the business user. Now, if you're talking about webs or site collections, right, then that's the business user in the business unit. But what if I'm talking about web application and farm? Who's my business user then? Central administrator. They're still a business user. They don't know how to set up a WCF or an ASMX web service to run properly. They don't understand the web.config. They don't understand how to provision an IIS website on each box. They don't understand how to manage that so that all of the web front ends get updated simultaneously. SharePoint does. SharePoint has built all of that sort of technical set of functionality in so that they can just click on new, fill out a couple of text boxes, and say go. Right? Boom, boom, boom. And it just shows up on all the right servers. Later they come, hey, I want to add another app server. Let's turn on this service. It just deploys everything. Right? All the bits go out there, all the latest bits. All of the necessary configuration is done for them so that all of the web front ends are done the same way. So our business user that we're empowering in this case is the farm administrator. It simplifies our developer life because we don't have to write custom deployment kinds of things in order to get our stuff out there and scripted and so forth. We don't have to worry about the concept of, hey, we've got 16 web.configs on each server that we have to go and update, because we can use SharePoint's framework in order to manage all of those pieces. So it's hosted in SharePoint. That's the number one. Second one is that it's a scalable shared service. Right? We can set it up so that this farm makes it available to other farms. We can, I think it's called publish and connect, or connect and publish, whichever way you want to talk about that. It can be consumed by external consumers. You can start to make SharePoint your com plus minus sort of environment for non-SharePoint applications. So SharePoint grows to be even more valuable from a, hey, we can just manage these middle tier components like we used to be able to do in com plus way back in the day. There is something called, in the .NET framework, it's called, I think, Enterprise Services. I'm pretty sure that that's what it's called, which is sort of the core functionality of com plus that's baked into the framework that nobody uses. Why don't they use it? Because there's no managerial infrastructure. SharePoint provides that managerial infrastructure for the service application framework. But it's not for the faint of heart. You're not going to build one of these every day. You're going to build one of these when you really need one, okay? Because you've got a problem. You've got too much processing going on in your web front ends, right? Or you need to centralize that state, or you've got that cross-platform kinds of things. Now, the other big thing is this is completely extensible. So if you want to do something really, really cool, you're a commercial software company, right? You've got some specialized way that you want to be able to do something, sell it, and roll it out to everybody. If they've got SharePoint, they can implement it, right? So it's really cool from that perspective. Service applications also provide all of these sets of functionality. Right, so they can provision new things. Literally, the administrator goes and says, run this PowerShell commandlet, right? Run this PowerShell script, go to the page and click new, run the farm configuration wizard and just select a checkbox, and it does everything. It rolls it out to the right boxes. It makes it so they can turn it on and off on whichever app servers they happen to want to run it on today. Right? They don't have to understand the underlying infrastructure that makes that happen. Of course, we've got optional management pages. We can now use claims. How many people are using claims already? Wow, that is a much bigger group than I expected. So because these are baked into SharePoint, and SharePoint is claims aware, all the requests are going through SharePoint, which makes these claims aware as well. So that's kind of a big deal. We get automatic backup and restore of all of our secondary state. We can auto-provision databases, and they'll automatically back them up. When you say, SharePoint, back yourself up, they can include your service application as part of that backup and restore. So you don't have to build that separately either. Of course, you get some kind of a load balancer built in, but if you want your own load balancer, you can substitute there, round robin, with whatever you want, least busy or sticky or whatever kind of load balancer you'd like. I wish this was easier, actually. You always have to implement a load balancer, even if you just want to use their default one. It's kind of like, why isn't it the default? If there's only one, and that's the one that you have to use unless you're going to build your own, it seems like that should be built in, but it's not. Of course, you can also write your own custom permissions. So you know how SharePoint has the 33 permissions? You can make your own permissions and say, hey, I'm going to check for this whenever somebody is trying to do something with my service application. And of course, they also provide just for free, here's the people who can administrate my service application. You don't have to write anything in order for that to work, okay? So here's a little SharePoint history. So SharePoint has had to solve this problem over and over again, and every time they solve it, they get better at it. So the first time, they said, oh man, in 2001, we really didn't have some kind of a multi-box solution. We were very much not scalable. We need to scale better in 2003. So they created something called, I don't see the name up there. Oh, there they are, shared service portals. Shared services portals, which basically said of the 20 portals that you could create in 2003, you can go create one that's dedicated for doing My Sites, or you can go create one that's dedicated for doing search, right? And then you would tell the other portals, because everything was portal-based, right? That kind of became site collections later. But so this portal is going to basically use that one over there for this service. And so they tried to use SharePoint as the underlying framework for how they were going to sort of roll this out. It worked not very well. So in 2007, they abandoned that idea, and they went to something called a shared service provider, an SSP, which eliminated the shared services portals, which also happened to be SSP, right? So that was convenient. This gave us the ability to say, hey, we're going to go ahead and roll this out not as individual portals, but we're going to say this one site collection can have this capability and this capability and this capability. They were grouped together, though. The problem was that if you wanted to use this search and this set of My Sites, but they were in different SSPs, you had to make a third SSP and sort of duplicate all of the configuration and functionality and data so that you could have that sort of separate grouping of things that you wanted to be able to do. That was very limiting from that perspective. And of course, not at all extensible. You got an SSP and it did what it did, and that was it. Right? We only got those baked ones. Search, user profiles, audiences, My Sites, BDC, and Excel. That was it. That's what we had. You wanted to write your own? Hey, go make a WCF. Oh, that's right. WCF didn't work in 2007. Go write an SMX web service, right? And then write all the management, all the deployment, all the pieces in order for some business user, your central administrator, to be able to handle that. All of your own deployment, everything had to come from you. Now that's baked in to the SharePoint 2010 Foundation. Yeah, look, SharePoint 2003 server, SharePoint 2007 server, SharePoint 2010 Foundation. This comes with the product that is free with purchase, right? Free with purchase. So if you've got Windows Server and you've got SQL Server and they're all running 64-bit, yes, I know, your database has to be 64-bit. What in the world? So you've got a 64-bit server and you got a 64-bit database, then you can run this for free, right? Which is pretty cool if you think about it. This is really powerful. This is the .NET framework taking on a whole new level of capability. I always think of SharePoint as sort of the .NET framework extensions, right? You take advantage of the .NET framework all the time. Now you can take advantage of the SharePoint framework, which extends .NET. Anyway, so here's a bunch of the benefits, right? Now we get service applications where you can say, hey, when I build a new web application, I want to associate myself with that individual service app and that service app and that service app. Instead of associating with a group of SSPs, you associate individually with each service application within SharePoint. Of course, it's managed in central administration, built on top of not SMX, but WCF. So if you've got Windows services or other remote protocols that you want to use, you can just bake those in. If you want to write the code directly into your service and not call a WCF service at all, you can do that. Right? So it's very flexible. It's very extensible. Hence this talk. So let's talk about extensibility. How am I doing for time? I can't see that clock at all. Am I good for time? 10:30 and I get until what? 1? No, that's not right. What is it? I don't know actually. What time? 11, so I have 30 minutes. Okay, I think we can get there. So a few examples. Let me just quickly go through these. So offloading processes like Excel services, performance point, search. Those are really CPU-intensive things, and so they made service applications for them. There's, what, 36 service applications in SharePoint 2010, I want to say? Centralized state. Web analytics is a good example of that. They call it a web analytics, and it puts it into a common singular sort of store so that you can query it later. Managed metadata, one specific list of valid truth. These are our true set of valid values you can choose from. So it's a common centralized state is the way I think of that one. Cross-platform. Managed metadata is also cross-platform because you can call into this set of domains from anywhere. Or these are my keywords that I want to use everywhere. So you can sort of a global set of keywords or a global set of values. What would you call that? Domain, a global domain. And search is also cross-platform. Some other examples, what do I want to call this? Oh, there's custom service examples. So what if you wanted to create one of these? So I said like a resume crunching service. You go ahead and set up a public website where people can upload their resume. Well, do you want to crunch that resume and read through and put it through your proprietary process on your web front end? No, you want to throw it over the wall to some dedicated set of application processing servers that crunch through that and stick it into the database separate from the web front ends. So it would be a good service application example. I already talked about the Who's Online. Maybe you want to create a My Company sandbox solution gallery in one farm and then tell all your other farms, hey, go get the sandbox solutions for our infrastructure in this one location. So that's what I'm thinking, cross-platform. So those are the three reasons why I think you're typically going to implement these. Otherwise, you're going to just go back to the traditional WCF service. All right, so now down to the nitty-gritty. So how do you put together a service application? Now, as far as I could tell, I couldn't find any really good information about how to do this. I mean, really, really nuts and bolts kind of information. So what I'm about to share with you is just from my hard knocks experience. So take it with a grain of salt. This is my perspective on how it works. First thing you need to do is make a service. In my opinion, it's much easier to make a service and test a service without the entire framework in the way. So go out and make sure the service does what you want it to do. So what do you have to do that, right? Make an SBC, make a contract with your behavioral and your data stuff if you've got some, deploy it to the web services, deploy another client config file to the web client. Those are in the SharePoint root. That's the new name. Remember in 2003 we had the 6.0 Hive. In 2007 we had the 12 Hive. And now in 2010 we have the, no, SharePoint root. It's not the 14 anything. Why is it not the 14 anything anymore? We don't say 14 because SharePoint root is going to be good for 15. SharePoint root is going to be good for 16. We've got one common place where, depending upon the version that you're on, you'll know where the infrastructure files are housed, right? So that they can move them someplace other than this horrible location. I don't know if they'll ever move them, but they really should. All right, so then deploy the DLL to the GAC. Why the GAC? Oh, man, GAC rhymes with what? Yeah, full trust, but why? Play my game a little bit. So GAC rhymes with what? Hack? Yeah. Flack? Smack? Crack? Whack? Sack? Nothing good. It doesn't rhyme with anything good. But bin rhymes with win. However, we're trying to build a farm solution, right? Something that's going to work on every single server everywhere. Right? We need to GAC this DLL so that it can be run from a non-HTTP context. We're going to be picking this up from some service application context, which won't necessarily have any kind of an HTTP identity. Right? It's going to have its own application pool. It's going to have its own identity. No HTTP context. All right, so once that's working, you're going to go test it, and you're going to make sure your WCF service does what it's going to do. That's the simplest approach. Go make your service, get it done. Get at least a hello world working, right? Then once you've got the service there, the second thing you need to do is build your service application. That's 5 components, minimum. 5 classes. You're going to create 5 different classes in SharePoint. Those 5 classes I'm going to talk about in depth at the very end of this talk. Service, service instance, service application, service proxy, and service application proxy. That's 3 server-side and 2 client-side classes. 5 classes. Just generate 5 classes. Bam, 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 bam. Give them nice names with those suffixes. See the star? The star is your name. You put your name and then give it a suffix .cs or .vb or whatever you like to use for your language. Okay, does that make sense to everybody? 5 classes. About those 5 classes, I'm going to talk about what each one of those does and how they kind of look together and how they work and blah, blah, blah. Okay? Now, and I'll talk you through the details about how you build out that basic. So that's all you have to do in order to make a service application work. Right? Build a client to consume it, and you're good to go. However, there's a whole bunch of optional pieces that you can add on. This is an extensible framework. So I've got 9 or 10 that I've identified that once you have your service application up and running and you know that you can make your calls, then you can add additional things. The first thing that I suggest that you add is a post-deployment PowerShell script that you're going to run during the post-deployment as a developer, so that you don't have to go into the browser and click through the turn it on this server and make a new one on this server and associate it with a group on this server, etc. Instead, you're going to write a PowerShell script that does those things so that every time you deploy, it goes and sucks everything out, pushes it all back out there, and then does those things that you would otherwise have to do in the browser, right, in a PowerShell script. Why? Because you as a dev don't want to bake that into your feature receiver, right? You don't want that to happen every time somebody deploys this in production, right? Instead, I'll tell you what you put in your feature receiver in just a minute, but instead, you're going to put it into a script that just runs on post-deployment. I like to call mine post-deploy.ps1 and stick it right into the project. I think that that's the easiest way to make it happen. I don't have my project packaged up right now, so I hope to do that yet this week. If you want a copy of my service application project, just so you can see one that works, you can just roll it out and make it go. Open up the Visual Studio project, set the URL for your site URL, and deploy, and just see how it works, right? If you want that, I'm going to try to upload that to mindsharp.com. If you just go to mindsharp.com, click on free resources, look for my name, Todd, you should see Service Application Framework stuff, okay, in the next week or so. I just want to make sure I've got a nice, clean version that I'm giving out to you guys, right? Not something that's got a bunch of goofy stuff in it. Well commented, blah, blah, blah. Okay, we do have one that's working, but I don't want to just give you what I've currently got because it's dicey. And not only that, after you download it, it's dicey. It's just my stuff. It's my ideas about how it works, okay? So look for that in the next week or so. Mindsharp.com, free resources. All right, so the first thing that I suggest that you do as a dev is write a PowerShell script that's going to automatically turn stuff on that you would otherwise have to go into the browser and click through in order to turn it on. Second thing that you could do, it's an optional thing as well, is create alternative ways of making new service applications. Do you have to do any of these? No. Why would I ever have a service application that does not empower the business user to turn it on, to make a new one? Maybe I've got a background service, and I'm going to manage it in code to turn it on and off. And I don't want it to be surfaced to the business user. Right? So if that's the case, then I won't provide any of these mechanisms for creating a new one. But you're probably going to want to make a new screen. You're going to want to make some kind of a mechanism by which you're going to turn it on for them. Maybe you're going to do that directly in the feature receiver. They activate it, and they get one. They deactivate it, it goes away. Right? Or maybe you say, well, when you activate it, it becomes available to you. That's the most common approach, right? Then you go to the service application screen, and you click New, and they get to make one. And then they get to say which servers it's running on. That's the norm. However, maybe they need to script it, so you've got to create a PowerShell script, or better, a PowerShell commandlet, right? So that they can turn it on and off the way that they would turn other stuff on and off. Remember, who's your business user here? Farm administrator. If you've got a farm administrator worth their salt, they're going to want a PowerShell commandlet, because then they can script the stuff. I'm not saying that they will know how to do that yet. By the way, I do have one rule about PowerShell. I don't get to talk about PowerShell at this conference. But whenever I talk about PowerShell, here's my one rule. If you're a farm administrator and you can't prove that you can restore this farm, you don't get to use PowerShell. Because the #1 way to destroy your farm in SharePoint 2010 is PowerShell. Oh yeah, absolutely. No doubt about it. I've heard so many horror stories already. Some guy went and ran a PowerShell script that reassigned permissions so that everything in the entire farm was permissioned to him and nobody else. He was trying to add himself, you see, but another guy went and he ran a PowerShell script and it replaced every content database with one content database. So all web applications were pointing to one place, which of course didn't have the content in it. You can really mess up your farm with PowerShell. There is no Control-Z. There's no undo, right? You say go, bam, you pipe that thing and it's done. Okay, so if you want to hear about PowerShell, I'm going to talk about PowerShell, the power of the pipe, at the SharePoint conference in October or whenever it is in the fall. Okay, or make a web application create page. Make a new.aspx in the _admin your project and make it so that they can go click on new and fill out some details. Make an application pool. I'm going to tell you what goes in there momentarily. Other optional things that you can do. Oh, here we go. The new page, the manage page, the properties page. Right, so you can make pages for them to configure each of those service applications. New makes a new one, and then once they've got an instance running, then they can configure that. Right, so that they can say this instance has this service application running on it, and that service application has these configurations. They can make as many different service applications as they want, and you can give them a manage and a properties page. Please think about what goes on a manage page. Stuff to manage a service application. What goes on a properties page? The characteristics. You wouldn't believe how many of the out-of-the-box stuff are just, they're like, well, I don't know, let's put both the manage and the properties be the same page, right? Or we'll just stick it on the manage page, and it's a whole bunch of properties. It's like they didn't even think, one's called manage, one's called properties. Why wouldn't you? Okay, you get the idea. You can optionally set up publish, right? So you have to go implement an interface in one of those classes that basically makes it possible for somebody to click on publish, turn it on, say the Boolean is true, it is on, and then they can click on publish, and other farms then can come and connect to it. Those other farms connect to it so that all the configuration is in their configuration database as if it's local. What's the difference? The service endpoint just doesn't end here. It ends over here. And as long as your authentication, authorization mechanisms handle this endpoint from this farm, you're good to go. Right? So you claims people are way ahead of the game, or Kerberos people at a minimum. You can allow them to identify the administrators. That's free. You don't have to do anything to make that happen. And you can set up your own custom service application framework permissions so that your service application has a Todd permission. And anybody granted the Todd permission will be checked, and if they don't have the Todd permission, they can't do the certain thing. Right? So you get to choose what those service application permissions look like. They're custom. You can also auto-provision custom databases. So you can go into your code and you just implement another interface in one of those classes and say, hey, whenever somebody says they want to make a new one of these, SharePoint, please go make some databases for me. Here's the format of the database. Make a database so that I can store my data in my own databases. In addition, I can say, hey, SharePoint, I also want you to be able to back up my databases. So whenever they back up SharePoint, please back up my databases too. Remember, that's the concept of the managed metadata or the search database or whatever, where they made their own custom databases that SharePoint is managing, which is pretty cool if you think about it. Custom timer jobs. What if I want to run a timer job that runs against my service? Hey, that's pretty cool if you want to think about it. Right? Think of the who's online. Every minute I want a timer job to wake up on the one who's online server, right? And go get everybody out of memory and stick it into a database. I don't ever have to talk to the database real time. That's a timer job happening, right? And I can set up my own timer job for my custom service. And then finally, you can create your own custom load balancer, which sounds like a lot of work to me. But if you really, really need sticky, or you need some other mechanism by which you choose which server you're going to allow to run this next request, then that's important. All right, all done with the concepts. Now let's talk about the details now. How does this all fit together? This is specifically the 5 classes. The 5 classes. Well, the end game is to get some client, right, to call your WCF service. If I was going to add anything, it would be off to the right of service application on the bottom right there, would be a line going off to your service. Now, you can build your service or your functionality directly into the service application class if you want, right? Or typically, or often, they'll implement it so that the WCF service is sitting over here, it just does what it does, and the service application makes calls to it. So how do I get the client to get the service application to call WCF? That's the question. And they way overcomplicated it. I mean, there are so many abstracted layers of abstraction. It's like, wow, I guess that makes it very extensible. I'm not sure that you needed to expose all of that. Couldn't you have done some of that for me? So the first thing that you need to get is the service context, or you can also get the operational context. That's something SharePoint manages for us. The operational context seems like it's just a little bit more powerful, but the SP service context is typically readily available when you're running something. So you're on a client, you say, hey, give me the SharePoint service context. Then you can ask the service context, hey, which one of the application proxies that's running out there should I call? Give me the application proxy. So it says, well, here's the application proxies, here's the group of them that you can use. Here's the one you're after. So go make a call to this one. And here's an instance of the default application proxy. Or if you've got even more complicated scenarios, you can get a specific one instead of just the default one. Anybody seen anything that implements something other than the default one? Have you seen anything? No. So typically, I think you're going to just say, hey, give me the default one, because other scenarios would be really complex. Give me a specific service application proxy that's running. But that's possible. So you get a service application proxy. The service application proxy is going to call the service application. And the service application is going to call the WCF service. So what are all those other classes for? What's a service? What's a service instance? What's a service proxy? Those are the underlying base classes of these, the basic worker classes. So you're going to have to start with the top right-hand corner there and make a service. I'm going to talk in depth about what a service is momentarily, okay? Each one of these has a slide. The service is basically the characteristics. Anybody make a custom field type before? What do? First, you inherit from one of their field types, right? And then you say, this is my field type. This is my service. That's all I'm saying. I'm establishing that I have one, right? I get one of those per farm. So I set up one instance, typically during the feature receiver, that says, whenever this thing gets activated, then I want to say, hey, SharePoint, you have a new service. This is what it's called, okay? The second thing I'm going to do is set up a service instance. Anybody ever been to services on server in central administration? That's just a listing of all the services. When you click Start, it says, oh, make a service instance on this server. So it's going to be running on this server. What does that do? Provisions the IAS website that's going to make it possible for people to make calls to your WCF service. That's effectively what's happening. It's called provision. So now that I have a service running on that server, it's got the IAS website with the endpoints so that I can make calls to it. The service application will get spun up by the application proxy when it's needed. So as the service application is needed, that's what actually talks to your WCF service. So you see the first three, right? The server-side ones. Service, just characteristics. Second one, service instance, on-off switch, right? Third one, service application, what talks to WCF? And I'm oversimplifying, but do you at least see how those three pieces work together? And do you see how overcomplicated it is? Just believe me, it's overcomplicated. The middle two there are service proxy and service application proxy. Now the service proxy is basically, hey, I have a service that could be running somewhere on this farm. You get one service proxy per farm. This is so that the client can have in the service context, remember I told you the SP service context or the operational context will know about the application, the group of service applications that are running. How does it know which ones are well, the service proxy gives it that information. So the service proxy is just characteristics about your application proxy. The application proxy will be created and instantiated as a default one so that you've got an instance that's running on the server. The client can then say, hey, service context, please look at the group, find which service proxies are available, and give me the instance of one called the application proxy. What does the application proxy do? It makes sure that the service application is instantiated and makes calls to it so that it can make calls to your WCF service. Okay? At least right now you can shake your head and go, oh, I understand what those 5 things do. But I went ahead and listed them on slides just in case. So first thing you're going to do is you're going to create 5 classes. Each one of those classes is going to be public. You're going to inherit from a base class and potentially implement a simple interface. Everybody understands that, right? You're going to decorate it with a GUID, a system.runtime.interruptservices.GUID. Why? Because these will potentially be serialized. And secondarily, because you might want to use replaceable parameters to refer to those classes. So you're always going to decorate your public classes with a GUID. Second thing you're going to do is you're going to include the default CTOR, right? The constructor that serialization requires in order to rehydrate something. They're just going to call that default empty constructor. So those are requirements. You have to do that for all 5 of those classes. Ideally, you also override type name. Now you might be thinking, type name? Why would I override that? Because for some hideous and stupid reason, I don't know, I haven't figured this out, instead of using display name to display stuff on all the screens in central administration, they use type name. And if you don't overwrite it, then it's going to say, my company dot my cool service application project dot cool stuff instead of some nice name. So I highly recommend that you implement type name on each one of these classes and give it a nice descriptive name so you know which one is being shown on that screen. All right? And like most of SharePoint, every server in the entire farm has to have these bits. How come? Because some farm administrator might go to that server and say, services on server, yes, start. When they say start, those bits have to be there in order to run. Right? So we have to use the WSP framework to deploy these out to the right location. Okay, so here's each component. How much time do I have now? I can't see. 5, 6 minutes? It's a good thing it's on the slides, okay? So first thing, service implements these two things, the SPIAS web service, or if you're just going to bake your calls directly in, you can just use the SP service. You don't have to do the whole IAS web service thingy. That's just for WCF support. The iService administration ties it in so that it can talk to central administration and whatnot. You give it a name, you give it all the details about how you create the application, create the proxy, and where your create URL is. How do I create one of these guys? If you don't give it a URL, then new won't show up. Okay? Instances of each of these services can be found. There's a property of the service called instances where each services on server has been turned on or off. Right? So then service instances is started or stopped. And it only implements inherits the SPIAS web service instance. Long names, but they all start with SPIAS web service. Chop that off, and it's basically what you'd expect it to be. Right? The names aren't that complex when you start to sort of whittle them down and don't look at that first little bit there. Only one of these per server. Right? So when they say turn it on, it's on for that server. Right? When you say turn it off, it's off for that server. Okay? Defines the public interface that we're going to consume. So it tells basically the underlying service application framework, here's the web methods that you can call into the service application, which is going to implement those web methods to actually talk to the WCF service or be the WCF service. It's fully functional whenever at least one of these is turned on. Right? So if anybody went to services on server and said start, then this will be available for them to make calls to. And this is what populates the drop-down list in the new. So if you're in the Service Application Framework area, and you click on New, this is that list, whatever your service instances are. One of them has to be online in order to see it there. And then called in sequence using the pluggable load balancer. Service Application, this is what talks to the actual WCF service. Right? So this one you're going to put all of your basic bits in. This is all the implementation, really. It establishes where your SBC file is. It also talks about where your management properties are. Because each service application instance is going to have the ability to have a... I think it's really silly that they said the service application instance is on or off, and then the service application, you can have multiple instances of the service application instance. So it's the instance of an instance, if you want to think of it that way. But the simplest thing to do is just understand that the instance is on-off, and the service application, you can have multiples of those, right, that are talking to that one base. All right? The service endpoints, then. So you can use your typical SBC. Don't miss the fact that you can deploy these either to the ISAPI folder or have it auto-deployed by SharePoint into the web services subfolder. So when you deploy your web.config into the web services, that details all of the endpoints that you'll have available for that service, right? You know, all of the crazy stuff you put into that XML file. Or, in my opinion, you can actually set it up so that SharePoint can auto-deploy that and use the MEX, M-E-X, the metadata exchange endpoints. SharePoint will automatically do that for you now and just call into your existing web services instead of having the web services being deployed along with your service application. I already talked about the auto-generated endpoints. And all of your bindings, this is WCF talk now, right? So the concept of the ability to say, hey, how am I going to make this sort of call into a service that I don't know about? Well, I'm going to rely on SharePoint to do that. So we have to set it up in our code to say, here's what your endpoints look like, SharePoint. So when somebody makes a call, you know how to talk to this WCF service. And then all the magic numbers that go into that XML file, which is crazy. You can actually eliminate most of them. So if you're just copying somebody else's, try eliminating most of the magic numbers, and it'll probably still work, because they're just using the defaults. They're using a tool to generate that, and the magic numbers that are in there are just the default, so that you know that you could change those if you wanted to. 99.999% of the time, you don't change anything, right? So, service proxy, this is the first client-side one. This one basically just says, hey, I have something that some external thing can talk to. It's over there. It's that service. So it's sort of the mirror of the service on the client side. And then it's a factory for making service application proxies. So if you make a request to SP service context, SharePoint's way to talk to the framework, and there isn't an application proxy, they'll make one using the service proxy. Okay? And then the service application proxy, that's the fifth one. That one is for actually making the consumer talk to the service application and getting the service application to send its response back to the consumer. See how that works? I think let's just leave it at that, because you see the details up there, but there isn't anything to really highlight per se. Oh, administrative pages. The new .aspx page, these should all be deployed to admin, and they should be administrative pages, not layout pages, not application pages. Right? Those, when you configure up the, hey, here's where my administrative page is, you don't have to say it's in _admin, it'll assume that. But you can optionally do any one of these three, right? Or all of these three, right? It's totally up to you. If you don't have a new one, then you're not going to be able to new them up. You're going to have to new them up through PowerShell or through custom code or something else. Okay? I already talked about these more or less. So consumers then, this is the last little bit. The consumer has to be written so that it can talk to the service application proxy through the SP service context. How does it do that? It's horrible. This is, in my opinion, the most complex part of how this works. So whatever consumer you write is going to have to call into dynamically generated WCF channels. These channels will dynamically create calls using lambda expressions. Now, you can do simple non-lambda, but there's not very many examples out there of how to do that. Okay, so just understand that you're probably going to want to write a class that simplifies those calls. That one class is going to make it so that the typical client can just make calls into what look like local methods. Those local methods then translate into those sort of complex WCF channel calls. And those channel calls then call into the service application proxy, which talks to the service application, which talks to the WCF service, which comes all the way back through the channel to your client. Right? And now I can use this framework, which is managed by SharePoint, wherever I want, including connecting it to other farms and all that kind of stuff. So how do you develop one of these? And I don't have much time left, but let me quickly just tick through this, because this was the most challenging. Where do I start? How do I get this done? Right? So the first step is make your WCF service. Maybe even host it in IIS and prove that it works. Right? The second step then is to test it, making sure that WCF test client or something like that, you're going to run into all kinds of issues with like anonymous access, and does your authentication protocol, claims-based, and all that kind of stuff work or not. So you have to work through those kinds of things just as a normal WCF service first. Make sure it works. Then make your 5 classes, 3 server and 2 client. Make them all public, decorate them with GUIDs, put the default constructors in, set the type name, all that kind of stuff, right? Right. Then go ahead and add a farm feature. In your farm feature, you're going to create 3 things. You're going to create the service. You get 1 per farm. You're going to make 1 service instance per server. I iterate through them using a for each loop. You're going to make 1 service proxy. Right? So that every time I deploy this, my service is ready. I can go to services on server and start it. I can go to new, click new, and say OK, or run a script or whatever. I don't have a new page on here because I'm trying to keep it as simple as possible, right? Then set up your proxy groups so that you've got that web application association. Go to a web application, you can new it up. Use PowerShell to auto-create it in your post-deployment. That's the ideal way. That way you don't have to go to services on server and click start. You don't have to go to the service application page and click new or run some kind of PowerShell script. Right? Instead, it's just happening every time you deploy. But it's not part of the deployment. It's just your dev environment post-deployment. It's not baked into the code. Do you understand the distinction I'm making there? That's a huge advantage. It just saves you tons of time. And then finally, go ahead and create a consumer page. Those are the primary things you must do to get a service application up and running. Then you got those 9 or 10 optional things I described in those other slides. Yeah? So, watch Minesharp.com. You should see a service application out there. I call it the time service because I try to keep it as simple as possible. Go get the server time. We've added in a little call where you can say, and what server did that run on? So that we can see the load balancer working. So that as we make calls, we can get the load balanced effect. But it's all of the minimal set of pieces that you need in order to make a service application framework work. Just Minesharp.com, free resources, look for my name, Todd, Service Applications, okay? Make sense? Hopefully this was helpful. I know I didn't do a demo, but I got you like the basic bits of information that's just lacking out there on the internet. So have a good day.